Good afternoon everyone, welcome to the channel. In today's video I want to talk about optics clustering. The full form of optics is ordering points to identify clustering structure. So this is actually a modification of DBSCAN clustering about which I made a video previously, and this is another clustering technique that works well for data which is densed or forms dense clusters. So let's see an example about this clustering algorithm. So as usual, I want to import required libraries. Okay, so import numpy as np, import matplotlib as matplotlib dot pyplot as plt, from sklearn import datasets, import optics, from sklearn import metrics. Okay, so these are our required libraries. Now I want to create data. Data sets, make circles. In samples, let's select 500. Shuffle will be false. Factor 0.4. .03. So this is noise. Random stat 42. Let's check the shape. So the data has two features. Y represents the levels. Let's visualize this data. So plt face color, let's pink. Scatter, provide the first column, then second column. For x-axis, font size 25. This will be y-axis. Let's set data partitions. Font size 30 and plt dot legend. partitions, then font size, let's say 20, title font size, let's say 20, okay. So this is how our data looks like. So we can see there is certain space between the two circles. So 1 denotes the inner circle and 0 denotes the outer circle, and this factor part only this factor part controls how much space will be between these two circles. And this B box to anchor part actually moving this legend from inside the figure to the outside. Okay, now just like the previous video, we will see two cases. So this is case 1. So let's perform optics clustering. So optics max EPS, let's say 2, and min samples, let's say 24. Then optics, we have to feed our data, then we can get the labels from this line. So max EPS is the maximum neighborhood radius. So this is actually not constant. In case of DBSCAN, we selected EPS which was constant, but this is the maximum. This is variable actually. This is not constant, and this is the minimum number of samples that's required to be in a neighborhood for a particular sample to be considered core point. Okay, now let's run it. Let's check the unique. So we have two levels, 0 and 1, which is what we expect because our data has two clear partitions. We can also check the counts of the unique levels. So let's mention 2. So this is the known criteria, and let's copy. This is the predicted. So same number of samples in both the levels. So we can also check it by this line. So it returns true. That means every value of the predicted results matches with the known criteria. We can also see it from accuracy score. which is 100%. So now let's visualize. Results. So let's copy view code, paste it. Now this will be labels, and let's change few things. This will be optics clustering results. Clusters, and so we can see the prediction by optics clustering, and it matches completely with the generated data. Okay, so but now let's consider another case. Okay, so another line I think I would like to show. So optics dot labels, optics dot ordering. Color, let's say green. Line width 3. So the y-axis is showing the labels predicted by optics. So two types of labels, 0 and 1, and we have equal number of zeros and equal number of ones. We can see from here. So this is what this plot is showing. Now let's consider case 2. Let's give another heading. Clustering, mention case 2. So let's copy this line. Let's mention that 2, 2, 2. So I want to keep these two fixed, but I want to change a parameter. So by default, the value of xi, let's say, is 0.05. So when we perform here, by default it was 0.05. But now I want to reduce this value. Let's say 0.034. So xi basically controls the maximum distance between two samples. Okay, let's run it, then we can understand it better. I think it's okay. Okay, now we can check the unique labels 2. Okay, so previously we had 0 and 1 when xi was 0.05. Now we have reduced it. Now we got some noise. Let's check few other things. Okay, so we can we can see there are so many noise. 226 have been assigned -1 as label. So these are all noise. 24, 0 and 2251. So I think the inner I think 1 is the inner circle. So the inner has been predicted correctly, but there are some problems with the outer circle. And let's visualize and see what can be the reason. And we can also see that this line will not be true like the previous one. So this is false, previously got true. And matrix dot accuracy score, maybe non criteria and levels 2. This is only 54% compared to 100% in the previous scenario. So finally, let's visualize optics clustering results. This is case 2. Let's copy these lines and change. So this is levels 2. Let's change these things as well. This will be case 2. Let's change this as well. Okay, so this is the prediction of optics clustering when we selected xi value 0.034 compared to 0.05, which is used as default, and we got a lot of noise. So all the rates are noise. The how to say yellow or orange, yellow probably 0, and the inner circle has been predicted correctly. Now this is the original, this was the prediction of the case 1, which was quite similar with the generated dataset. But when we reduced the distance between two samples from 0.05 to 0.034, you can see in this position there is gap which is more than 0.034, but it is probably less than 0.05, which is here by default 0.05. So because there is this gap, because of this gap, I think these points are not considered to be in the same neighborhood with these points. So that's why we need to choose these parameters carefully if we want to get good results, both in case of optics or DBSCAN, which I explained in my previous video. Okay, one more thing I want to show is show this plot in this case as well. So this will be optics 2. Let's change the color to red. Now see this one 0 and 1, but here we got some disruption. So there are a lot of noise. This -1 this is also -1, which are noise, and only these few are 0. I think only 24 0, but this has been predicted perfectly, and already we can see that this gap is kind of large. That's why this problem occurred, and this 0.034 is actually not big enough to cover this distance. Okay, so that's the end of this video. Thanks for watching.